So the next example that I provide in the slide, so actually this activity is for when we have a physical class, but since we don't have a physical class this semester, so I just give this which will be part of your own exercise. So what is the question asking for here is actually the exercise on evaluating the evaluating the volume. So this one is volume, because we know that how can we know this is volume? That is because of the integrand here is equal to 1, and also it is stated that what is the instruction here? You are given a complete triple integral where actually you can just directly find the volume, just integrate one by one with respect to z, y, and then x, we get the answer. But in this case, actually, just to just practice on determine the correct limit for the correct solid. Okay, just exercise. But just to be honest, you can't see this kind of question in exam. Just to give you an exercise, how can you get? So from the previous example, from the solid, you can you have to determine the limit. Now from the limit, you have to determine the solid. Okay, so this exercise is actually normally when you have to change the order, not change the order, but change the system or the coordinate system. So let's say your instruction here is in Cartesian coordinate, and because of there is a complexity for you to solve this using Cartesian, so you have to solve maybe using the spherical coordinate that you have to learn next on the next section, next video, and maybe you need to change into a cylindrical coordinate. So for that, you have to be able, from the limit given, you have to be able to determine the solid, and then from the solid, you have to find the limit in terms of r and theta, and so on. Okay, so look at the first example, where in this case you have okay, how can you read that? So I think in our previous video, the previous example in double integral, we changed from Cartesian to polar. I give you some examples, really, just like this one. You are given a complete double integral, but you have to solve using polar coordinate. So now you have to be able to read to know all the information provided. So to know what is the solid, what is the region that we have, then you have to be able to read all the information from the given limit here. So firstly, you have the what type of okay, firstly, for example, for E, so we have the order of integration is given by dz dy dx, which means that we have the y, x or xy solid, right? Which means that your region is lying on y-x plane. Okay, so then for the region where you can read from the last two order of integration, you are given the limit of x is constant. So x is constant from -3 to 3, and then y is function negative square root to positive square root of 9 minus x squared, 9 minus x squared. Okay, so the last two here will tell you the region, the shape of the region. Okay, so because the x here is constant, so you can determine the shape of the region from the equation provided, where the equation here, when you rewrite this one, so you have actually y equal to plus minus square root of 9 minus x squared. When you square both sides, so you will have y squared equal to 9 minus x squared, where this will give you a circle. Okay, so now you know that your region, which part of the circle with radius 3 and center at the origin. So when you sketch your region, So based on the equation that you have, firstly you have to refer to the equation that you have. You have a circle with radius 3, centered at the origin on y-axis plane. So now you have to determine which area that we need to shade. Okay, just like we done in the double integral before this. Okay, so how can we read that? So in this case, we can see that our x is constant. When x constant, so you have to draw a line, okay, vertical line. So you can see that from the given limit, x is lying between -3 to 3. So it looks like it can be negative and it can be positive. Now look at your based on your line that you provide. So now you want to read your y. So y here, the lower bound belongs to the negative part of the y, which is part of the circle where the y is negative. So now it looks like that is the lower bound of y, and then you have the square root. So this is also part of the circle with radius 3. So now we want to check whether the right side of x also have the same lower bound and the upper bound. So now based on this line, so we look at, because x also can have a positive 3, so that's why I can draw the line here. So the lower bound also belongs to the negative value of y, part of the circle, and the upper bound also part of the circle where y is always positive. So meaning that the area that we can shade on the circle is all over the circle. So now we know that our region is a complete circle with radius 3 centered at the origin. So that is our region. So now how about the information, the sketching of the solid? What is the shape that we should have? So for that you have to read from the Z. Okay, so remember last time I already mentioned again and again, for you to determine the limit. Okay, now you are given a limit, you want to determine the solid. That is the example now. But from the previous example, you are given, you have the solid, but from the solid you want to determine the limit. So that is something another way around. Okay, so last time I mentioned to determine the limit of the last two integral, you have to look at from your region. Where now, how can you have the region? So you have to look at the last two integral. So from the last two integral, it representing the region, the shape of the region. Now, for the first integration, which is z, this, how can you get the limit of the z? It's from the solid. But now you have already the limit of z, but from the limit that you have, you can determine the shape of the solid. Okay, so the z that given to you, so z is 0 to y plus 6. Okay, so now you can imagine you have something lying on the xy plane, and your floor, you are standing on xy plane, and your floor, your lower bound is 0, meaning that you are standing right on the floor where z is equal to 0. And then who is covering you? So the surface that covering you is a surface of y plus 6. Okay, so now we want to sketch the y plus 6. Okay, so y plus 6, z equal to y plus 6. So let's say, okay, first if we have no idea, then we have to sketch the trace on zy. So we have positive. Okay, so at z it is 6, and when z equal to 0, so we have minus 6. Now we want to sketch in 3D. This one is a trace, so then what is the surface looks like? So let's say I'm using the standard orientation. So now your graph is got 6 here. Sorry, not that way, but the other way. This one. straight, something like that. So this is 6, this is minus 6, right? And then when we do the projection, maybe I should extend this. I should extend the x. So now, so that is my new zy plane. So this is z and this is y. And on that new zy plane, I have a new line. And that line is parallel. So this is negative 6 and this is 6. So then I just continue the line. So that is my flat plane. Okay. So now what is the solid that we have? So then we imagine on y-axis plane, you have a circle with radius 3, so minus 3, 3, minus 3, 3, and you have a circle, radius 3. So x, y, z. Okay, when you do the projection, so you have a cylinder, right? Cylinder, and you cut that cylinder by this plane. Okay, so it looks like your surface. So you have to cut, your lower bound is 0, z equal to 0. So this is your floor, and your upper bound, your roof. So you have this one is coming from the where this one is at 6. Okay, and that is, so this what we call that, this surface is a plane which is part of the plane of z equal to y plus 6. This one. Okay, so meaning that your solid is actually only that one. We don't have this. Okay, so that is your solid. So when you are standing in that solid, so you can see that you can verify whether your answer is correct or not. So your z, your lower bound is 0, which is the floor, and your upper bound is part of z equal to y plus 6. Okay, and then how about your region? So your region is this one, where you obtain that from your information that provided in for y and x. This one, y and x, the last two integral. Okay, so you have to, okay, so this example 2 actually an exercise to obtain a solid from the given limit. Okay, so I hope that you can try for the 4B yourself. I can guide you a bit on how can we get the solid from the 4B here. So in this case, we have dz, dy, dx, which means that your region, okay, because the last two is y and x, so we have the y-x solid, the region is lying on y-x plane. So now we read for the limit of z, so the limit of z will tell you the solid. Okay, you can get the z, because we know that to determine the limit of z as the first integration is coming from the solid. So the z here is based on the limit provided, z is 0 to 1 minus y. So because for z equal to 0, we know that we are, let's imagine that you are standing on the xy plane. So your lower bound is the floor, because we have here the lower bound stated that z is 0, it is a floor. But then your cover, the surface that covering you is the plane given by z equal to 1 minus y. So we want to get an idea what is the the surface looks like. Of course, it is a plane, but now it is important for us to, but if you have a quick imagination, then you can just directly sketch, but sometimes it's quite confusing, so that's why we need to sketch one by one. Okay, so to obtain the surface of z equal to 1 minus y, so here I provide the trace, and then when I convert into 3D, so this is the plane looks like when we need to do a projection. Okay, so that is the information that you can get from the dz here. So now how about dy dx? So dy dx tell you the shape of your region. So now based on the information provided, we can see that x constant, which is negative 1 to 1, and y is function x squared to 1. So in this case, I start with the function y equal to x squared. So I draw the quadratic. So the quadratic here, because we know that I have the yx squared, this one, and then y equal to 1, and then we have the line of x equal to 1 and x equal to minus 1. So how can I know this one is the 1 and minus 1 should be here? Because we know that when x equal to 1 or minus 1, so the value of y is equal to 1. So that's why we can sketch here when y is at y equal to 1. So the intersection point is at 1 and minus 1. Okay, so that is the region. So now how can we know that we have we should shade the, because we know that when we're talking about the region, you should shade, right? You should shade the region. So now how can you know that this is the region, that the area that you need to shade? So it is again based on your order. So x constant, you have to draw a vertical line. So from the vertical line, you can, from the x limit, the limit of x provided, x is from minus 1 to 1. So it looks like x can be negative and x can be positive. And then look at the y. So because of it is stated that the lower bound of y is the quadratic, and the upper bound is the y equal to 1. So that's why I shade the area here. So you have to be careful here, because sometimes your region can be down here. So your region can be down here. So you have to be able to read the limit carefully. Okay, you have to read the limit carefully. Okay, so now we have to combine all the information that we obtain from the region 2D, and also the surface that we have. Okay, so it looks like when you sketch the region here, so you have this one. This becomes your region. Okay, because what is the region? Region is something that you are lying on to. Okay, you are lying. You yourself, imagine you are standing inside that solid, and your feet is on XY plane. So when you are standing over here, you are somewhere over here and you're looking down. So the dominant shape that you can see lying on XY plane is this one, which is, you can see this particular shape, right? That is your region, where you can see that from this sketching. Okay, so now we do the projection. So we do the projection along the Z. So we have this. So from your region, we do the projection, because we want to create the solid, right? But the solid is basically part of this shape and also this surface. So that's why from this region, I have to transform into 3D, where I have to do a projection along Z. Okay, so when I do the projection along Z, so this is the solid that I get, but then this is not the solid that you can have from the given limit provided, because of you should combine the solid of this and also the solid of this, the surface of this and the solid of this. So what can I say? That I have to cut this solid by this plane. So this is another standard sentence that you can have every time you have the example, whether in the book or in the exam question, so there is a word, the solid is cut by the which plane. So let's say in this case, this solid is cut by this plane. So what is the shape that you can have after you cut the solid by this plane? Okay, so look at here. Your Z is passing through at 1 and Y also at 1. So that's why I put the 1 here and also 1 here. Something that just to notify ourselves that it's become the boundary. Okay, so you draw that. Okay, so then this is something not easy to be done, because you can imagine, I'm sure that you can imagine your solid looks like after you cut the solid by this plane, but it is something not easy to be done on the paper. But I understand that as long as you provide me all the traces and all your traces, all your sketching are correct, then I'm sure that your solid also correct. Okay, but sometimes it is hard for us to sketch very well, right? Okay, so now after you cut, so that plane will give you something like that shape, right? So that is your plane, your flat plane. Okay, so what is the solid left after you cut the original solid by the plane in the purple here? So then the only solid left is something at the bottom, right? So you can't see this anymore. So you don't see this anymore. So this is gone after you cut that. Okay, so that is your solid now, which means that if I redraw, so this is X, this is Y, and this is Z. So you still have this. Okay, this is at 1 and this is at 1. So yeah, so this is the flat plane given by Z equal to 1 minus Y. And imagine you are standing in this solid. So now, just to verify whether our solid is correct or not based on the limit provided. So your Z, who is your lower bound? Z equal to 0, and your upper bound is 1 minus Y. So that looks correct. But then, what is your solid looks like? Sorry, what is your region looks like? What is the region? I already mentioned from the double integral before this. Region is the dominant curve that you can see when you are standing outside the solid. Okay, I understand that maybe you confused with my word. So imagine now, you know that your solid is lying on XY plane. Your region is lying on XY plane. But how can you determine the dominant curve, dominant region for your solid? Imagine you are standing outside and you're looking down. What is the dominant shape that you can see? You cannot see the purple plane here, right? But you can see, the thing that you can see lying on XY plane is this. Is this one. This one. Isn't it? Which is your region over here. Okay. Again, region is the dominant curve that you can see when you are sitting outside the solid. This one. Okay, so I just give you the result. But then if you're still confused, then just do it yourself and then rewatch my video again and again. But if you still get stuck, and let me know, and maybe I can help you.